how do you automatically detect when a statement contradicts your source material? We'll define a DSPy signature that verifies citation faithfulness by comparing a text claim against a provided context. The code will show how to structure input fields for the facts and statement, then generate both a boolean faithfulness result and specific evidence from the context.
Class check citation faithfulness, DSPy, signature. Verify that the text is based on the provided context. Context, SDR equals DSPy. Input field desk equals, facts here are assumed to be true. Text, SDR equals DSPy, input field. Faithfulness, bool equals DSPy, output field. Evidence, dict SDR, list SDR equals DSPy. Output field, desk equals supporting evidence for claims. Context equals, the 21-year-old made 7 appearances for the Hammers and netted his only goal for them in a Europa League qualification round match against Andorran side FC Lustranes last season. Lee had 2 loan spells in League One last term, with Blackpool and then Colchester United. He scored twice for the U's, but was unable to save them from relegation. The length of Lee's contract with the promoted Tykes has not been revealed. Find all the latest football transfers on our dedicated page. Text equals, Lee scored 3 goals for Colchester United. Faithfulness equals DSPy. Chain of thought check citation faithfulness. Faithfulness, context equals context, text equals text.
This demonstrates DSPy's declarative signature pattern, where language model behavior is defined through structured input-output field specifications. The code creates a verification signature that takes context and text as inputs, then produces a faithfulness boolean and evidence dictionary as outputs, using Python type hints and descriptive metadata to define the interface. The key aspect is how this approach lets you specify the task requirements cleanly while leaving the execution to DSPy modules. The pattern works by encapsulating the task's data contract in a reusable class that DSPy modules interpret at runtime. When the chain of thought module processes this signature, it automatically generates the reasoning steps needed to evaluate whether the text aligns with the context, returning both a binary assessment and supporting evidence in the specified format. This separation allows the task definition to focus purely on the interface, while the module handles the implementation logic. This approach matters because it provides a structured way to define verification tasks that require both assessment and evidence collection. The code shows how to create a fact-checking component where the expected input-output structure is explicitly declared through the signatures fields, making the requirements clear and modifiable. This pattern becomes particularly useful when building validation pipelines where consistent, well-defined interfaces improve maintainability and reproducibility. Let's break it down line by line.
Class check citation faithfulness, DSPy, signature.
This creates a DSPy signature class that defines the interface for citation verification. It declares the input fields, context and text, and output fields, faithfulness and evidence, without containing any implementation logic, serving purely as a structured type definition for this verification task.
Verify that the text is based on the provided context.
This docstring defines the core purpose of the signature class, validating whether the input text is factually supported by the provided context. It establishes the verification contract that the subsequent implementation will fulfill.
Context, SDR equals DSPy. Input field desk equals, facts here are assumed to be true.
This declares context as a required string input field using DSPy, input field, explicitly marking it as the factual reference material that the signature will verify against. The desk parameter provides documentation that this field contains assumed truth facts for citation checking.
Text, SDR equals DSPy, input field.
declares the text input parameter as a required string field in the DSPy signature. This defines the claim statement that will be checked for faithfulness against the provided context.
Faithfulness, bool equals DSPy output field.
Declares a boolean output field named faithfulness that will contain the verification result of whether the text matches the context. This defines the expected return type for the signature's output.
Evidence, dict_str list_str equals DSPy. Output field, desc equals supporting evidence for claims.
This declares an output field that returns structured evidence for each claim. Using a dictionary mapping claims strings to lists of supporting context snippets. The explicit dict_str list_str type annotation enforces this format, while the description clarifies its role in citation verification.
Context equals, the 21-year-old made 7 appearances for the Hammers and netted his only goal for them in a Europa League qualification round match against Andorran side FC Lustranes last season. Lee had 2 loan spells in League One last term, with Blackpool and then Colchester United. He scored twice for the U's, but was unable to save them from relegation. The length of Lee's contract with the promoted Tykes has not been revealed. Find all the latest football transfers on our dedicated page.
This defines the factual reference text stored in context, which the check citation faithfulness signature will use as ground truth when verifying claims. The string contains verifiable details about player statistics, loan spells, and contract information that serve as the evidence base for the faithfulness check.
Text equals, Lee scored 3 goals for Colchester United.
This defines the test statement will verify against the provided context. The string makes a specific claim about Lee scored 3 goals that will be checked for factual accuracy by our citation faithfulness module.
Faithfulness equals DSPy. Chain of thought check citation faithfulness.
This wraps the check citation faithfulness signature in DSPy's chain of thought module, forcing the model to generate explicit reasoning steps before returning the final faithfulness and evidence outputs. The pattern makes the verification process transparent by exposing the intermediate logic used to evaluate whether the text aligns with the provided context.
Faithfulness, context equals context, text equals text.
This executes the check citation faithfulness signature as a chain of thought operation, passing the provided context and text for evaluation. The call invokes the defined logic to verify if the text's claims are supported by the context, returning both a Boolean faithfulness result and supporting evidence. This is the core evaluation step that performs the actual citation checking. DSPy signature validation pattern. This code demonstrates how to define a structured signature with check citation faithfulness that explicitly declares context and text as inputs while enforcing faithfulness, Boolean, and evidence, dictionary as typed outputs. The desc parameters in input field and output field serve as lightweight constraints, guiding the LM's interpretation without manual prompt tuning. When wrapped in chain of thought, the signature automatically includes reasoning steps, but the core validation logic remains tied to the declared fields and their relationships.
The evidence that contradicts itself holds the only truth.